Hello everyone, welcome back to my YouTube channel. So in today's video, we will go through the Swift network and infrastructure. This is one of the most important topics in the international payments. The entire session will be about understanding how global banks communicate with each other for the international payments. So in this session, we will be covering some topics like Swift GPI, BIC codes, RMA, UETR, ISO 20022, and the infrastructure that the bank used to connect to SWIFT. In simple words, this video will help you understand the plumbing behind every cross-border payments. Okay. So before we look at the infrastructure, let's first understand what SWIFT actually is. So SWIFT stands for your Society for Worldwide Interbank Financial Telecommunication. It was founded in 1973 by major international banks because earlier banks were using telex messages which were slow, manual, and error prone. Today, SWIFT connects about 11,000 plus uh, banking institutions and corporates across 200 plus countries and supports millions of financial messages every day. It is the headquarter of the SWIFT is situated at Belgium. Um, so the most important part is to know about SWIFT is, so SWIFT does not hold or does not move funds. Actually, SWIFT only sends secure financial messages between banks. In simple words, SWIFT is like a postal system for the banks. So when you send a courier, the courier company carries the letter for not the actual property mentioned inside the letter, right? Similarly, SWIFT carries the payment instruction or payment message, not the actual money. Now that we know what SWIFT is, let's see the network. Let's see the SWIFT network, how it is structured. So on the left hand side, as you can see, we have bank A, the sender. On the right hand side, we have bank B, the receiver. So bank A does not directly send a message casually like an email. It uses Swift approved software or Swift approved products like Alliance Access, Alliance Lite 2, right? The message then travels through the SwiftNet link. So this SwiftNet link is a secure connectivity layer, and this may use a leased line or secure internet-based connectivity. Then the message reaches your Swift operating centers. For example, let's say there are Swift operating centers in Netherlands and one in USA. So this operating center will provide resilience. Resilience means, in simple words, resilience means if one operating center faces an issue, then the network can continue using another center. For, for example, the primary operating center is located in Netherlands and the backup resilience center is located in USA. If due to any reason the operating center in Netherlands fails due to some reason, the operating center located in USA will come to the picture. So when we talk about Swift network architecture, we do have this payment message service as well. So we will get to know about this two payment message service of the Swift in the coming sessions. Okay. Now, if banks are sending messages to each other, how does Swift know the correct bank address? That brings us to the next topic, which is BIC. So BIC basically stands for your bank identifier code. This is also called your Swift. So sometimes BIC is also called a Swift code. So this is like your postal address on the Swift network. This is like the address of the bank. This is also called your address of the bank on the Swift network. So we can identify the banks with the help of this bank identifier code. So this is how a BIC looks like. So it has 8 to 11 characters in total. So you can see it's combination of alphabets and numbers. So the first character, the first 4 characters basically represent the institution, represent the bank. So you can see HSBC is the bank. So the first 4 character is HSBC. The next 2 characters represent the country, or it's a country code. For example, in this case, GB is Great Britain. The next 2 character identify the location. This 2 will identify the location, and the final or the last 3 characters basically identify the branches. If there is no characters mentioned here, or you only XXX is mentioned in at the end, that basically means this is the address of the head office. So how do you read this HSBC GB2L triple X? This basically means this is HSBC Bank of Great Britain, located in London, and it's a head office. So in real banking project, big codes are extremely important because they tell the payment system where to route the message. So if the big is wrong, or big is outdated, or big is inactive, or the big belongs to the wrong branch, the payment may fail or may get delayed. That's why banks validate the bigs using your Swift ref directory or internal big reference data. Okay, now that we know how banks are identified at using bigs, let's try to understand the different services that Swift provides for sending messages and files. So basically Swift provides 4 message services. One is Fin, Interact, Filect, and Browse. So Fin is a traditional store and forward message services. So it is used for your empty messages. So this service is used to communicate the empty messages like MT103, MT202. So empty messages. In simple words, Fin is like your secure mailbox. So a bank sends a message, Swift stores it, and then forwards it to the receiver. That's why the Fin service is also called as store and forward messaging service. Let me repeat it again. A bank will send the message through Fin service. Swift will store it, and then it will forward it to the receiver or the next or the beneficiary bank basically. Interact. Interact is more modern and supports real-time messaging. It is used for your ISO 20022 MX messages, queries, confirmations, GPI tracking, and cross-border payment reporting flows. Uh, think of Interact like a real-time API style conversation. It's like a real-time API style conversation between banks. Next is your FileAct. So FileAct is used for file transfer. This is used for file transfer. For example, if a bank has to send thousands of payment records, it will use FileAct. Then browse is a web-based access. It is used for your reporting, directory services, or accessing certain Swift tools like Swift ref directory or any other tools through browse. Now that we understood the services, let's look at the actual products banks use uh, to connect to the Swift. So basically, the Swift products are called as Swift Alliance products. These are the tools and interfaces banks use to connect, route, secure, backup, and archive. So these tools, Alliance products are used to connect, route, secure, backup, and archive the Swift messages. Now let's divide this slide into three simple groups: core interfaces, uh, connectivity and resilience, and operation support. Let's first go with the core interfaces. So we have these products under the core interfaces. So for Alliance Access, so this is used mostly by the large banks. It's enterprise grade, supports high volumes, integrates with your payment hubs, and handles Fin, Interact, FileAct, and FinPlus flows. Alliance Entry is a smaller setup for institutions with lower complexity. Alliance Lite 2 is a cloud-based Swift solution, Swift connection. Sorry, it is suitable for smaller banks, corporates, and lower volume users. Alliance Cloud is a strategic cloud-based routing for institution moving away from heavy local infrastructure. Coming to the connectivity and resilience, we have the Alliance Gateway. Alliance Gateway acts like a secure entry point to the SwiftNet. Now, what is SwiftNet Link? SwiftNet Link is a local software layer required to access the SwiftNet services. Then we have Alliance Connect. Alliance Connect provides different connectivity packages such as your bronze, silver, and gold. Then we have the Alliance Connect Virtual. So Alliance Connect Virtual is a cloud-based is again a cloud-based connectivity option that allows the financial institution to deploy Swift VPN connections in approved public cloud environments like your AWS, Azure, or Google Cloud. Instead of using physical VPN boxes in the bank's data center, the bank can connect securely from the cloud to the SwiftNet. Third, we have the operations and support. So under operations support, we have the Alliance Lifeline. This is used for your business continuity. If primary connection is disrupted, the bank can use a disrupted. The bank can use a disrupted. The bank can use a backup route. For example, we have seen that Netherlands and US example in the previous slide. Alliance Remote Gateway. It's a secure way for an institution to access Swift services remotely without necessarily hosting and managing the full gateway infrastructure directly inside its own premises. Then we have the Alliance Warehouse. This is used for your message archiving and migration, mostly message archiving and migration. Then we have a service bureau or shared infrastructure. This means a third-party provider manages your Swift connectivity for an institution. So, in a real banking project, if a bank is migrating from, say, Alliance Access to Alliance Lite 2 or any Alliance Cloud, that is not just a technical migration, it impacts your operations, cutoff times, message routing, testing, security, and business continuity. Okay, now let's move to one of the most important Swift security concepts, that is called RMA. RMA basically stands for your Relationship Management Application. So in simple words, RMA is a bilateral authorization or the whitelist system. Or in simple words, we can say RMA is permission to communicate. Okay, so let's say an example. So before bank A can send Swift message to bank B, both banks must authorize each other. So think of it like this. So even if you know someone's address, you cannot enter the secure building unless your name is on the approved visitor list. So RMA is that approved visitor list for the Swift messaging. Okay, let's take an example of this one. So we have SBI on one side, and then we have a Deutsche Bank on the other side. So for example, SBI and Deutsche Bank wants to exchange messages. So first they have to agree on a correspondent banking relationship. Then SBI will send RMA authorization to the Deutsche Bank. Deutsche Bank sends authorization back to the SBI. Only after this bilateral permission is established, then only message can flow. So without RMA, the message may be rejected even if the BIC is correct. Apart from RMA, we have one more called RMA Plus. So RMA is a broad authorization that, as we have already understood, it can allow all message types once a relationship is established between the banks. But RMA Plus gives more control to the banks. It gives granular control. For example, a bank may say, I will only accept MT103 from this counterparty, but not MT202. So that is possible through RMA Plus. It allows the banks to have more granular control on the message communication. RMA setup is a very critical checklist item. If RMA is missed, payment can fail even on day one. So that's an important point that you should know. Now, once bank can communicate, the next challenge is tracking the payment. That is where this Swift GPI. This particular technology comes into the picture. So Swift GPI stands for your Global Payment Innovation. So it was launched to improve the speed. It was launched to improve the speed, your transparency, traceability, and control in cross-border payment. So this GPI was launched to improve the speed, transparency, traceability, and control in your cross-border payment. So before GPI, if a customer asked, say, where is my payment, where is my international payment, the bank often had to send manual investigation messages to the multiple banks in the chain. It was like calling different couriers offices one by one and asking, did my parcel reach your location or reach you? But GPI changed this by introducing the structured tracking. The first important feature is your UETR, that is unique end-to-end tracking reference. This is like the tracking number of a payment. The second is your GPI tracker, where banks update the payment status. The third is your SLA. The GPI banks commit to faster processing, transparency of charges, preservation of remittance information, and confirmation of credit. The fourth is your stop and recall. If there is a fraud or wrong payment, the bank can try to stop or recall the payment while it is still in the chain. The fifth is your case resolution. So this standardizes investigation instead of relying on the scattered manual messages. Now let's try to zoom into this UETR, which is a part of GPI. So as I have already told, UETR stands for unique end-to-end transaction reference number. It's a 36 character number assigned when the payment is created. This is basically assigned when a payment is created. You can also call UETR as the tracking number of your cross-border payment. So it's a payment tracking number. The UETR, the most important thing to know about UETR is UETR must not change as the payment moves through the chain. So the ordering bank will create the UETR. Correspondent bank will the ordering bank will create the UETR. Correspondent bank will carry the same UETR, and the beneficiary bank confirms using the same UETR. So think it like this way. It's a courier tracking ID. So if the tracking ID changes at every city, you will never know where your parcel is. So similarly, if UETR changes in the payment chain, tracking is never possible. So in MT103 format, UETR is available in the in block 3 under field 121. So this is how the UETR is defined in MT103. In ISO 20022, for example, in PEX 008 message, the UETR appears within the payment identification tag. So in real banking project, one important testing scenario is generate a payment, pass it through all the systems, and confirm that UETR remains unchanged. UETR remains unchanged end to end. Okay, now that we understood the tracking, right? Let's look at SWIFT security and sanctions. So SWIFT is a neutral financial messaging cooperative, but it operates within legal and regulatory boundaries. It does not decide your political sanctions on its own, but because it is based in Belgium, it must comply with the Belgium and EU law. It must have to comply with the Belgian and EU law. That is why certain institutions from Iran or Russia were disconnected from SWIFT during sanctions. Now, one important clarification is SWIFT itself does not screen every transaction for sanctions. So individual banks are responsible. Actually, individual banks are responsible for screening their own payments against sanction list, your PP PP list, and other risk indicators. So in simple words, SWIFT provides your route. Banks are responsible for checking whether the vehicle is allowed to travel or not. So now let's talk about the customer security program or CSP. So in 2016, the Bangladesh bank hissed exposed serious vulnerabilities. So attackers used compromised SWIFT credential and fraudulent messages to steal around 81 million US dollar. So after that, SWIFT introduced this customer security control framework. So all SWIFT users must perform annual self-attestation and demonstrate that mandatory security controls are in place. So in short, to understand about CSP, users need to remember this one. It impose control, attestation, and remediation. That means all SWIFT users must perform annual self-attestation and demonstrate the mandatory security controls are in place. Now let's walk through a SWIFT message journey using a traditional FIN service. So let's imagine a bank. A bank A is sending an MT103 customer payment message to Bank B. Bank A is sending MT103 a customer payment message to Bank B. In step 1, the payment starts in Bank A's payment hub. Um, Bank A's internal payment hub. So this could be your payment engine, core banking system, or payment processing application. In step 2, the payment hub submits a message to Alliance Access. So Alliance Access will reformat or will format the message according to SWIFT standard, will validate the field, assign sequence numbers, and prepares it for submission. The message will then go to the SwiftNet FIN network. So in SwiftNet FIN network service, Swift will authenticate the sender using Swift infrastructure and then send the acknowledgement back to the Bank A. So acknowledgement, if something is wrong, Bank A may also receive not acknowledgement or negative acknowledgement as a message. So bank basically sends SCK and NAK. SCK basically means the acknowledgement, and NAK basically means the negative acknowledgement. SCK basically means message accepted and delivered, whereas NAK would basically mean message has been rejected. In step 4, so Swift operating center will come to the picture. Swift operating center will store the message and route it to the bank base queue. This is why we have already discussed. This is why Fin message service is called store and forward messaging service. Now bank base alliance access will retrieve the message, will decrypt the message, weld it, and then send acknowledgement back. Bank-based internal processing system. Bank-based internal processing system will process the message and applies the funds or route it for further processing. So if it's a GPI payment, GPI tracker will also be updated in the payment chain. Okay, and this is the end-to-end flow that is particularly common in their Fin service. Now let's compare this with the more modern Interact service. So in the Interact journey, the payment hub creates your ISO 20022 MX message request. So this could be your PEX 008 payment service, CAMT 056 cancellation request, a status query, or a GPI related interaction. The alliance interface will validate, the alliance interface will validate the XML schema that has come from the payment hub, and the alliance access will apply the rules, sign the message, and send it back to the SwiftNet Interact or SwiftNet link. SwiftNet Interact will authenticate the sender. It will authenticate the sender and route the message in a real time. The receiver bank processes the request and sends back a response or confirmation. The sender bank then updates its workflow, the GPI tracker, investigation case, or customer status, and then so here it is the end-to-end flow for the Swift messaging journey or the Interact service. So the key difference between your Fin and Interact is that Fin gives a store and forward service for empty messages, whereas Interact is a real-time request response for MX messages and modern services. So think of Fin like a secured mailbox and Interact as a secure banking conversation happening live. Now that we understood the theory, let's ground it or let's see how it actually happens or see with the real banking examples. So we have here two examples, one with the Standard Chartered Bank and one an example having some communication between PNB and Deutsche Bank. Going with example 1, so the big here you can see is SCB LGB2L. So let's try to decode it quickly. So SCBL identifies a Standard Chartered Bank, GB identifies the country Great Britain, and 2L points to the London. So Standard Chartered Bank being a large international bank would typically use enterprise level Swift infrastructure such as alliance access. Outgoing messages are created by the payment hub, converted to Swift format and passed through alliance access, and then submitted to the SwiftNet. Incoming messages come from SwiftNet into alliance access, these are validated and then routed internally. And then coming to the second example, so the PNB wants to send Deutsche Bank as its Deutsche Bank as its USD correspondent bank. So they have to first sign a correspondent banking agreement. Both banks exchange the RMA authorization. After RMA is established, PNB can send, say for example, MT103 payment message to Deutsche Bank, and Deutsche Bank can send payment 950 statement back to PNB. Without RMA, PNB's message would be rejected. So this two are a real life example that we see from the Swift point of view. And in real banking project, this type of setup is very common when a bank onboards a new correspondent banking partner as well. So now let's go through some 5 common Swift issues. First is big not found in Swift directory. This happens when the big is incorrect, or big is this happens when big is incorrect, inactive, or belongs to any bank that does not exist anymore. So the fix is to validate the big against Swift reference directory or any reliable internal reference database. Second, no RMA relationship. If a bank tries to send message without RMA authorization, the message will be rejected. The fix is to establish RMA before going live. Third is Swift infrastructure outage. So Swift itself has a resident operating centers, but the bank's local alliance access server may fail. So this can cause messages to go to queue and miss the cutoff times. So the fix is business continuity planning, backup connectivity, queue monitoring, and operational procedures. Fourth is your UETR not pass through. So if an intermediate bank, for example, if an intermediate bank strips or changes the UETR, GPI tracking will break. So the fix is to do end-to-end testing of UETR integrity. Fifth common issue is your message format errors. So Swift messages must follow strict rules. Wrong field length, invalid characters, missing mandatory fields, or incorrect dates can cause rejection. The fix is pre-validation and testing in the Swift test environment. And as a BA or tester working in a payment project, these issues can these issues you will mostly keep facing, and this issues can become your user stories, your test scenarios, defect root causes, or even operational process improvements. And with this, we come to the end of this video. In this video, we have learned that Swift is a secure messaging network, not a money movement system. We understood how banks connect to Swift using alliance products. We decoded the big codes and show how correct bank addressing is critical. We learned the difference between FIN and Interact. We understood the RMA as a bilateral authorization system between banks. We explored the Swift GPI and UETR for payment tracking. We also discussed sanctions, security, common issues, and so on. Hope this video will help you in your payment learning journey. If you enjoyed this video, please do like, share, and hit the subscribe button to remain informed about the upcoming sessions. Till then, keep learning and see you with a new topic. Bye.